And hello. Today we'll be looking at equivalent fractions and simplifying. So we probably have looked at natural numbers and integers. So now we'll be looking at a different kind of animal called fractions. So just a bit of history on fractions. They first kind of were brought up during the Renaissance. You learn a lot about that in history, and it was also a massive time for maths. And other areas of science as well. So they started thinking about, well, what happens if you have a number that is between integers? So let's say, what I mean by integers, let's say I have 2 and 4. Okay, well, we have 3 is in between 2 and 4. But what if I said, what's between 2 and 3? The numbers in between the numbers. Now that was a bit of a new kind of thought process, and that's where we get fractions. So what are fractions? Well, they look like this. You definitely have seen them before in primary school maybe. You might have 3, and then you have like a line, and you have 5. Now, just a little bit of jargon, but words that you need to know and you need to be able to associate with. So if I said the numerator, well, that's the top number of the fraction. It's the one above that little line. And then you have the denominator, which is the bottom number. It's below the line. And what are fractions? Well, fractions are actually very similar to this. Let's say 3 divided by 5. And this fraction, well, it's actually the exact same thing. And that's where we get the little notation for dividing from. Let's, when we write 3 line 5, 3, now the dividing sign, well, look, it's a line with a dot and a dot that represent these numbers. So it's actually just shorthand for 3 divided by 5, or just 3 over 5, a fraction. It's also the same thing as 3 multiplied by 1 over 5, or 1/5. All these 3 things are exactly the same. Now, this is something that is very, very important. A lot of people struggle with this, even in leaving cert and even in college and going on to any level of maths. It's really important that you understand that these 3 things are exactly the same. They're just different ways of writing it. We're going to be talking a little bit about equivalent fractions. And what do I mean by that? Well, let's say I have a whole unit, and the whole unit is represented by the circle. So 3 divided by 5 would be 3 circles, and you split it up into 5 bits. But let's use it just as one circle. Okay, one circle, I divide it into how many bits? 2 bits. So it's a half. Let's say we have one circle and we divide it into 4 bits. Now, I'm looking at only the shaded parts, so this is 1/2. So I'm dividing this into 4 bits, and I'm looking at 2 of the shaded bits. So that's going to be 2 over 4, or what we like to call 2 quarters. Now I have the full pizza again, or circle, and I divide it into 6 bits. So now I'm working with 6. So you'll notice the bottom number represents how many bits I've divided it into. And the top number, so this is the denominator was the bottom number, top number is the numerator, represents how many bits we're actually looking at. So this one, 3 bits are shaded, so it'll be 3/6. Now I've divided the circle up into 8 bits, and we've shaded 4 of those bits, so it'll be 4 over 8. Now, those are all fractions. What do I mean by equivalent? Big word, but you might, if you maybe forget about the valent, but equi. It sounds a little bit like equal. And what it actually means is just equal fractions. Fractions that are exactly the same. And these are all equivalent fractions. If you notice, see the blue shaded bit, blue shaded bit, blue shaded bit, blue shaded bit. It's the same amount of space out of the whole circle. These are all equivalent. They're all exactly the same. Now I know I've divided it up into different amounts, like this This circle here is divided up into 6 bits. This circle here is only divided up into 2. But the amount of the circle that's actually shaded is exactly the same in each of them. And that's what we mean visually by equivalent. It's the same amount of space that's taken up. Now, let's say we don't have circles, because sometimes we don't have that visual aid to kind of help us. How would you find an equivalent fraction? So let's say I had 2 over 3. Now remember, that's 2 shaded bits. If you imagine your circle, that's 2. You divided your circle into 3 bits. Your denominator is 3. And 2 of those bits are shaded. That's visually what it means. Now I wanted to divide the circle into 6 bits. How many bits would I have to color in to make it equal? Now, here's the trick that we do. This is the important part. If I have a fraction and I multiply the number, the numerator, by a number, and if I multiply the bottom number, the denominator, by the same, so let's say I said 2 times 7 over 3 times 7, that is going to still be that's still going to be 2 over 3. Now, this is some fundamental rule with fractions. If I multiply the numerator by something and I multiply the denominator by something, it's still going to be the same as 2/3. And we'll see later on why that is, but just for now, just trust me. So, I have 2 over 3. I want to make it 6. I want this 3 to become a 6. So what do you think I would multiply 3 by to make it 6? Well, oh yeah, and also I forgot to mention, we can multiply by a number. If I do this, and remember, it has to be the same number. If I multiply the numerator by something, and I multiply the denominator by something, that's okay. I can also divide the numerator by something, and I can also divide the denominator by something, and that's completely fine. I'm still going to have the same fraction. So those are the two things that are really important that you have to remember. Anyway, going back to this. 3, I want to get to 6. How would I do that? I can multiply it or I can divide 3. Those are A-okay. Well, if I multiply 3 by 2, I get 6. Well, remember, the rule is if I do something to the denominator or if I do something to the numerator, I have to do it to both. I have to do it to both the bottom and the top. So I've multiplied 3 by 2. I also have to multiply 2 by 2. So I get 4 over 6. So 2/3 is equivalent to 4 over 6, or they're equal. They're exactly the same. If I were to do the circles for them, I haven't actually done them out, it would be exactly the same amount shaded in. So these two bits here are really, really important to remember. If I multiply the numerator by something, and I multiply the denominator by something, I still get the same fraction. So 2/3 is exactly the same as 4/6. It's just another way of writing it. Okay, different one now. I have 18 is equal to 2 over 18 over 17, or 18 over 27 is equal to 2 over something. So what is it going to be here? 2 somethings. Now, think about it. Remember, I can multiply or divide, so I want to get 18 down to 2. So, can I multiply 18 somehow to get to 2? Not really, no. Can I divide 18 by something? Yes, I can. If I divide 18 by what? Well, remember, I could divide it by 9. So 18 divided by 9, that's equal to 2. And that still is okay, that rule here. If I multiply or divide, this is a division one, that's A-okay. So I've done something to the top, I have to do it to the bottom, to the denominator. So if I divide 27 by 9, well, that's going to be 3. So 18 over 27, that's the exact same thing as 2/3. And how did I get that? I divided it by 9. Okay, simplifying then. So I mentioned at the start we would be looking at simplifying. Simplifying just means making something simpler. Make it easier to read, simpler. So we sometimes say simplifying or the simplest form. So 21 over 35. Now that's a bit of a weird thing to visualize. How would you visualize that on that circle? Remember the circles we were looking at? How much of that circle would be shaded? How big is this? Well, just note, simplify just means makes things smaller in maths usually. It just means to make it a little bit more neat, make it smaller. So how would we make 21 over 35? Those are kind of big numbers. How would we simplify it? Well, think about it. 21 over 35 is equal to something over something. What number divides into 21 and 35? Because remember, I want to make 21 smaller, I want to make 35 smaller. And if I can if I can divide 21 and 35 by some magic number to make it smaller, what number would I pick? Well, I chose 7. And why did I choose 7? Because 21 is divisible by 7 and 35 is also divisible by 7. So 21 divided by 7, that's 3. 35 divided by 7, that's 5. So this is what we call simplifying, where I've reduced 21, I've reduced 35 by dividing it by the same thing. And I get 3 over 5. Now, again, 3 over 5, that's exactly the same as 21 over 35. If I were to do the circles, if I had a circle and I divided it into 35 bits, and I shaded 21 of those bits, or if I had a circle and divided it into 5 bits and shaded 3 of those bits, that would be exactly the same. Another way to think about it, this amount of number is exactly the same as this amount in decimal form, but we won't worry about that. That'll be for another day. Okay, some recap questions. Which is larger, 48 over 60 or 34 over 40? Now that's a tough question. How would you do that without a calculator, do you think? Okay, where is the mistake here? So 4 over 5, that's just equal to 16 over 20, which is equal to 3 over 4. What's gone wrong? So I'll give you a second to do those. Okay, which is larger? 48 over 60, let's simplify it to make it a little bit easier. 48 over 60, well that's the same thing as 4 over 5. How did I get that? Where did I get that from? Well, what did I divide 60 by? Because I remember I'm making 60 smaller. So if I divide 60 divided by 12, yeah? 60 divided by 12, that's going to be 5. 48 divided by 12, that's going to be 4. 4/5. Can I make that any smaller, do you think? Well, can I divide 4 by anything? Okay, can I divide 5 by anything? No. Well, I could divide 4 by 2, but can I divide 5 by 2? No. So that's as small as it gets, 4/5. 34 over 40. Well, if I divide it by 2, that's 17 over 20. Yeah? So now I've simplified both of these. I've simplified this, I've simplified this. I still don't really know which one is bigger. How would I get? Well, I have 20 here, 17/20. Yeah? I can't make it any smaller. Maybe I could make this bigger if I could get this to 20s. Yeah? So let's say 4/5. 4/5. Well, if I wanted to make it into 20, the denominator to be 20, what would I multiply by? I'd multiply by 4. Yeah? So if I do that below, I do it above. 4 times 4, well, that's going to be 16 over 20. Yeah? And that's, again, that's the same thing as 48 over 60. I've just simplified it small, and then I've grown it back up again just to make it to 16 over 20. So now the question is, which is bigger, 17 over 20 or 16 over 20? Which is bigger? 17, so imagine your circle, you've divided in 20 bits and you've shaded in 17 of them. Or if I divided in 20 bits and shaded in 16 of them. Well, obviously the 17 over 20 is bigger. So the answer would be 34 over 40. Okay, where's the mistake? 3/4 is not equal to 16 over 20. It's equal to 15 over 20. Because think about it. 4 times what is equal to 20? Well, it'll be 4 multiplied by 5 is equal to 20. So I have to multiply 3 by 5. That's going to be 15. But that's not 15, that's 16. So there's a mistake there. 3/4 is not equal to 16 over 20.